So he strongly believed that if you torture the data, it will confess to anything, because there are often more than one way to sample and interrogate your data. And we need to decide which approach is best is subjective, and it is open to bias. So that is again a good saying by Renuga. So data can be anything. Data can be numbers, data can be a facts, data can be digits, symbols, codes, graph. So we need to understand the differences between data and information. So in a nutshell, if you talk about a data, data can be anything. As we discussed, it could be a number, symbols, characters. On the other hand, if you talk about information, information is something about data. We are just putting into context. So information is completely utilized by humans in some significant way. So with that, they could able to make some decisions. They can forecast something, right? So in a short, I mean, literally, if you talk about in a short term, data is completely raw. It's an unorganized fact that needs to be processed. So data can be something simple and seemingly random, which is completely useless until it is organized. Right. So when data is processed, when data is organized, structured, or presented in a given context, so that we could able to make it useful. So that is why it is termed as information. Right. So information comprises of processed data, organized data, structured data. We are presented that in a meaningful context. Right. So again, it is further classified into three different types, like structured data, unstructured data, and semi-structured data. When you talk about structured data, it strongly follows a table-like manner. It is a straight table like rows and columns. It consists of rows and columns. It has a certain protocol to design your data. When it comes to semi-structured data, there is no predefined format. Like take an example of JSON. Like we have many objects. One objects may contain different key value pair. The other objects may contain different key value pair. It doesn't follow a table-like manner. Hence, it is termed as semi-structured. When you talk about the other hand, like unstructured data, there is no predefined rule, no syntax, no format, nothing. There are no rules and regulations to design your data. So like images, audio, video files, PDF files, flat files, everything will be considered as an unstructured data. There is no proper dimensions to define your data, right? So what is data analytics? So why data analytics is required? So we are completely surrounded by data, but we are starving for insights. Yes, of course, we have a lot of data. We are getting data from everywhere, right? So the next step is we need to process it to get some meaningful insights. So when it comes to a small scale industry or medium scale or large scale industry, at the end of the day, we need to make some strong decisions, strategic business decision, right? So we have data with us that is completely raw. We need to process it. So we need to use some tools and techniques to process it to make some strategic business decisions. So that is where the data analytics comes into a picture. So it refers to the process of examining your data sets to draw some conclusions about the information they contain, right? So what is the role of data analytics? So what is the role of data analytics? Anyone? So we know, like, we can collect data from various heterogeneous sources. With that, we could able to make some, we can process, by using some tools and techniques, we could able to process it. With that, we can take some strategic business decisions. Then what is the role of data analytics? Yes, anyone?
To identify pain points better and also to help solve complex problems.
Yes, that is one of the key things. Like we can, if we imagine, for instance, if we have a complex data, definitely it is very hard for us to discover some valuable insights with it, right? And also it is very hectic for us to extract some useful information. So it involves various tools and techniques. Thank you, Arifa. Thank you so much.
Yep.
So,
yeah.
So it involves the use of various techniques and tools to turn your raw data into an actionable knowledge. So which can be used for a decision making. And also, as Arifa mentioned, which is used to solve your problem. So problem solving. And also we can make some strategic planning. So there are many key components are involved in data analytics, like collecting the data. We need to gather the data from various heterogeneous sources. Either it could be in the via databases or DBMS, like relational databases, sensors, surveys, or any social media. So that is the initial step in data analytics. The next step is data cleaning. So this involves identifying and rectifying the errors, inconsistencies, or missing values in the data. So we have to make sure that your data is quality and reliability, right? And third step, like we can say data transformation. So data needs to be reshaped, or we have to convert that into a suitable format. We are collecting data in its native format. Either it could be a structured data or semi-structured data or unstructured data. The next step, we need to reshape it. The data may be inconsistent. So we need to normalize the data. We need to scale our data. We need to encode our data. Such kind of transformation needs to be processed before building any of the models, right? So a lot of key components gets involved, to process your data, right? So one is informed decision making, solves complex problems, and also it manages risks and fosters innovation. So here I have given some statistics on growing demand of data analytics. So according to the US Bureau of Labor Statistics, the number of job requiring data skills is expected to grow by 27.9% by 2026. So you can see the role in the graph, like data scientist has USD of 176,213. You can see the graph, like look at the statistics. So it is rapidly growing. Jobs in data analysis are growing rapidly. And also we can, they are offering some competitive salaries for data scientist roles. And leading organizations, they are actively seeking the data analyst talents, since a lot of technical skills are required to become a data scientist. So in the upcoming slide, I have mentioned what are the skills required for to become a data scientist or data analyst, right? So what are the essential skills required? So here I have listed down few steps here. The first and foremost step, we need to collect the data, then clean it and prep it. So data cleaning and preparation comes in the first place, followed with statistical analysis, data visualization, machine learning, programming skills, and domain knowledge. So, so there are several important skills and components often associated with data science and data analytics. So these skills are indeed critical for success in these fields. So let me briefly elaborate on each one of them. So first is data cleaning and preparation. So this is the process of cleaning, transforming, and structuring your raw data into a format suitable for analysis. So your data may have some missing values, your data may have some duplicates, your data may not be accurate, right? So we need to handle the missing values, we need to impute some missing values, we need to remove the duplicates, and also we have to make sure, ensure the data consistency. So these are the steps comes in data cleaning and preparation part. Then what is the use of statistical analysis? So if you want to summarize, for instance, let's imagine if you want to summarize or to interpret, or if you want to draw some conclusions about the data, then definitely statistical plays a vital role. So like descriptive statistics, if you want to calculate the averages of a particular column or attributes of field, then we need a mean value, right? So mean, median, standard deviations, hypothesis testing or regression analysis, descriptive statistics or inferential statistics. So these kind of statistics are used to summarize your data. So the next is data visual. So which mainly helps in presenting your data in a graphical or visual format. So which is making the stakeholders easier to understand, and also they could able to interpret the complex patterns and trends easily. So that is the main motto of using data visualization. So we are representing our data in a graphical way. All right, so that comes in data visualization part. And machine learning. So what is the use of machine learning? So it involves using algorithms. So in order to build predictive or descriptive models from the data, we need a ML. So this covers a wide range of techniques, including supervised, unsupervised, reinforcement, deep learning, NLP. So a lot of techniques gets involved in machine learning stuff. The next, programming skills. Yeah, so data scientists often, they need to write some code to manipulate the data or to analyze their data. So common programming languages for data science includes Python and R. So there are most competitive programming languages nowadays worldwide. They are using these two languages most often. So proficiency in these languages is valuable. Okay, and domain knowledge. Yes, sometimes in order to solve some complex problem, okay, or to answer some relevant questions, definitely domain knowledge helps you to ask relevant questions. They can choose appropriate data sources. They could able to interpret their results in a meaningful context. So understanding specific domain or industry you're working in this is a crucial part. So if you're a domain expert in a particular thing, then we could able to ask a lot of irrelevant questions. Relevant questions, you could able to interpret the, the results in a meaningful way, right? So these are the essential skills that are required. So I have elaborated a bit for each and every components. Skills and components. For data cleaning, your data is often messy and incomplete. So cleaning and preparing your data involves identifying and correcting errors. Okay, I have given, for instance, in an e-commerce data set. So cleaning might involve removing duplicate entries, correcting inconsistent product names, and also you can impute missing customer addresses. So this is data prep part. So you can see the examples. So line number 4, 5, the row was missing, and row number 1 and 2 has a same data, right? So we need to remove the duplicates. Look at the column B. We have a different date type format, so we need to we need to standardize this date format in a standard way. And we may have a missing or error values in column C, like a date column. So we need to fix this bug. And also sometimes in certain field, you may have significant changes in a particular value or particular string, textual value or numerical value. You may find some significant impact changes in a particular column. So you need to find that. So that we generally term that as an outlier. Okay, if any of the value is significantly impacting the rest of the values, we generally consider that as an outlier. So we need to remove that as well. So these are the steps gets involved in data cleaning. So statistical, as we discussed earlier, like to extract some meaningful insights, to identify some patterns, and to make some data-driven decisions, we need a statistical analysis, right? And data visualization, we are representing your data graphically to communicate your insights effectively, right? So like using bar charts, pie charts, or clustered column chart, or stacked column charts, or using cards, using donut charts. We can use a lot of charts to represent your data graphically. And machine learning, so it involves various algorithms to analyze your data. We can predict by using the historical data, right? And programming skills, or 2 programming skills are there for manipulating your data, like Python and OR. By using this, either you can go with Python or OR language. So mainly this OR language is specifically designed for statistical purpose. By default, they have some inbuilt statistical libraries, and also Python. Both are, very good languages, programming skills. There are certain factors to be considered before picking up the programming languages, whether you have to go with OR language or Python language. Okay. So Python is completely a versatile and popular programming language. We commonly used in data science and analysis. Even it has some extensive libraries like NumPy, Pandas, Matplotlib, and Seaborn. So NumPy is used for numerical calculations. For all the statistics, you can use NumPy. And for manipulating or analyzing your data, we have Pandas library. And Matplot and Seaborn. Matplot is a data visualization library. Using some codes, you could able to design a heat map, box plot, violin plot, histograms, bar charts. You can represent your data graphically by using Matplotlib library. So on top of Matplotlib, we have a Seaborn. That is an advanced visualization technique. Even by using that Seaborn, you could able to represent your data visually, right? And domain knowledge. So this knowledge is also a crucial part when it comes to a data scientist or data analyst. We need to understand the data in an efficient way. Only then we could able to make some strategic informed decision makings, right? So we need to understand the specific industry or field in which you are working with, right? So with this, we could able to make some more relevant analysis. So if you are a data analyst in the healthcare industry, you should understand the medical terminologies, right? And also the regulatory requirements to interpret your data accurately. So that is where the domain knowledge plays a crucial role in data science. All right. So what is the importance of data quality? So as we discussed earlier, we need to impute the missing values, remove the redundant layers, finding the duplicates, finding the outliers. We need to format the data in a proper way. So we will be doing a lot of prep, right, before building the model. So what is the importance of data quality? So if your data is clean and consistent, then we can make some accurate decisions. And credibility, effective problem solving, efficient operations. So with that, we can achieve the customer satisfaction. We could able to save the cost, and also we can get the better accuracy if your data is consistent. If your data is not consistent, then again your accuracy may be somewhere around like 50 to 60%. Again, we need to tune with the parameters, to play around with a lot of hyperparameters, right? So to avoid that, better we need to make your data clean before building a model. So these are the importance of cleaning your data. So also I have given a few instances about duplicates removal. A data set may contain duplicates data, so we can identify and remove it. Handling missing values, sometimes you may have incomplete data, so missing values will be addressed through imputations, right? And inconsistent formatting, data has inconsistencies such as dates in various formats. So month, date, year, or date, month, year, or year, month, date. So we need to standardize this to ensure the uniformity. And extreme data points would be present in a particular column or fields or attributes. So we need to detect and manage that appropriately to prevent the skewing results, right? So we need to find your data. We need to plot the data in a standardized normal way. So your mean should be 0 and the variation should be 1. If your data is skewed towards right or skewed towards left, then it means that your data point is biased to a highest value rather than the lowest value. So we need to normalize it. We need to scale your data before building the model, right? And standardizations. Yes, as I discussed, sometimes in a particular column, a few might be mentioning in kilometers, few might be mentioning in meters, right? So 3000 meters is equivalent to 3 kilometers, right? So I mean, when it comes to the units, they will take the highest value. The model is completely biased towards the largest value. So we need to normalize it. We need to format the data in a standardized way. Instead of you having a different units, we need to scale it in a standard units. So to get some accurate analysis and comparisons of your data. All right. So here I have given the role of statistics in data analytics. We know this is a backbone of data analytics. In order to get some quantitative foundations of your data, we need this statistical analysis. So we have a lot of roles here. One is descriptive statistics. So descriptive, inferential statistics, predictive, hypothesis, data validation. Maybe I can explain you one by one now. So what is the use of descriptive statistics? So in order to understand the variability within your data sets, we need this descriptive statistics part. Like we need to find the mean value, median value, mode, or standard deviation. So if you use these kind of statistics, which helps us to understand the variability within your data sets. And inferential statistics. So this helps us to draw some conclusion or to take some strong decisions about our data, right? Sometimes you may have a samples of data, right? So by using that samples of data, we are trying to draw some conclusion about a population. So we have a lot of techniques to use this inferential statistics like hypothesis testing, and we have a confidential intervals. So these two are essential for making some inferences. Maybe I can give you a bit more example about inferential statistics. For instance, you can consider, okay, let's imagine you are working for an e-commerce company and your team is responsible for analyzing customer purchase data to improve the sales and customer experience. Okay, by using descriptive statistics, you can start by calculating the average customer or the average purchase amount per customer, right? And also you can gather some data on the purchases made by 100 customers over the past month or over the past 2 years or something like that. So we can get a summary of the data. So that is where the descriptive statistics plays a role. And when you talk about inferential statistics, you want to make some inference about your entire customer base. So based on a sample of 30 customers, you can able to infer about the entire customer base, right? So you can calculate the mean purchase about, mean purchase amount for this sample. So we can estimate the population mean for all the customers. Let's say the sample mean is $78, and you calculate a 95% confidence interval, right? Within the range from 70 to 86. So with this, what we can achieve, 95% confident that a true average purchase amount for all customers falls within the range of $70 to $86. So we can come to some conclusion by using that 95% confidence interval. And next is predictive, right? So when you talk about predictive, again, to increase sales, you decide to build a predictive model to forecast a future purchase or future purchase amount based on some historical data. So we have some historical data with us. So a lot of customers are purchasing averagely in the ranges from 70 to 86. So I have some historical data with me. So by using that, you could able to build a model. Either it could be a regression model or classification or clustering. Again, it might vary. Let's discuss about this part in the upcoming slide. Okay. So we are considering these factors like the past purchase history, their website interactions, their customer demographics. So with this, we could able to predict like the future purchase amount for individual customers. Okay. And hypothesis testing. So if you want to test the hypothesis, that offers a loyalty program, right, which increases customer spending. You can collect data from two groups, one with a loyalty program and one without. So with this, you can perform a hypothesis testing to compare the average purchase amount in both the groups. So we'll be using some p-value. If the p-value is less than the significance level, like 0.05, then you may consider that the loyalty program has a statistically significant impact on customer spending. So with that, this hypothesis testing will help you a lot to, identify the impacts on customer spending. Okay. And the last one is data validation. This statistics is used to validate your data quality. Like sometimes you may have on outliers, right, to identify the outliers in the data. For instance, you can calculate a z-score. So z-score for purchase amounts. And if your z-score is greater than 2 or less than 2, your purchase, you can flag accordingly whether the value is potentially falling behind the outlier points or something. So this helps in ensuring that your analysis is not influenced by extreme values. Okay, sometimes your data or your model completely biased towards the largest value, right? So to avoid such kind of things, we need to ensure your data is not extremely or unduly influenced by some extreme values. So to predict that, we have a beautiful method called z-score. Okay, so a lot of this is again a kind of a statistical method to ensure your analysis is not influenced by the highest values, right? So here I have mentioned with one analogy how to calculate the mean, median, and standard deviation for the given data sets. And data visualization. Right. So when we talk about data visualization, as we discussed earlier, we are presenting our data in a graphical or visual format. So which is making it easier to grasp, or which is making it easier to understand our data set. So for instance, if you have 1 million rows of record, by looking at the data set, do you think, is it possible for me to come up with some solution by looking at my data sets, right? Or is it possible for me to get some insights about my data? Or if I want to get some quick decisions, do you think, is it possible for me to recognize some patterns by looking at the actual table?
No.
No, right? So it is a hectic task for us. And again, it's a time consuming, right? So we need to do a lot of steps to process it or to get some insights about the data, right? So to simplify, we have a lot of BI tools available in the market like Power BI, Tableau, MicroStrategy, ClickView, ClickSense, and Google has Google Studio. So we have a lot of tools available in the market. And based on the certain factors, according to your industry regulatory compliance, you can pick whichever tool you're comfortable with, right? So which simplifies the complex data and which enhances your data-driven storytelling. And also you can enable faster insights which aids in decision making, and also we can facilitate communication across diverse audiences. Okay, these are the benefits of using data visualization. So as we discussed, most commonly used or widely used BI tools are Tableau and Power BI. So these are the widely used data viz tools, so which is user friendly. And also each and every tool has some pros and cons. So we need to look for the security, we need to look for the cost per user, per license, and a lot of license stuff is also there, and free version is also there. When it comes to Power BI, for free version, they'll be giving you 1 GB storage, right? And if you are a licensed user like Premium or Pro, they will be giving you 10 GB. And also data refresh rate is high when you go with a licensed user like either Premium or Pro version. So there are, again, there are certain pros and cons is there. Each tool has their own benefits. We need to look into it. Right. So next is machine learning. So what is ML? So again, it is a subfield of AI. So subfield of artificial intelligence, which mainly focuses on the development of algorithms and statistical models. So which enable, we are trying to enable a computer system to learn and make some predictions or decisions without being explicitly programmed. So without being explicitly programmed, we are trying to make a machine to understand something. So what is the next way? Then the next question comes into your mind. So without being explicitly programmed, how a machine can learn, right? So it means we are feeding some input to the model. So we are feeding some data to the machine. So machine will learn based on the given data, and it started giving you started making some predictions or decisions based on the given data sets. So in other words, we can say it is a set of techniques and methods. We are allowing computers to automatically improve their performance on a specific task through data or through experience, right? So again, there are key characteristics and components of machine learning include, like, we need a data. Yes, of course, in order to make some predictions or decisions, we are starving for data. We requires a large amounts of data to learn from, right? So we need to divide the actual data into two sets. One is training set and test set. So training set is used to train your model, and test set is keeping it aside to evaluate your model, right? So let's imagine you have 100 rows of record. Out of 100 rows of record, 70 rows of, that is a good rule of thumb, like either 80-20 ratio or 70-30 ratio, you can split your data. So 70% of your actual data randomly we'll be choosing from the data set, and we are passing that data to the model. Okay, the model will learn from the given data, and we are keeping it aside a remaining 30%. The reason behind, we are trying to evaluate my model, how my model is performing to this data. So to evaluate or to validate my model, I'm keeping the remaining 30%. So to keep it aside to test my model. Okay. So as of course, we require a massive amount of data, and we have a lot of algorithms available in the market. I mean, we need to process our data, and with that, we could able to extract some patterns. Again, these things can be categorized into different types, like supervised, unsupervised, reinforcement, and deep learning. So each suited for different types of tasks. So let us talk about this bit later about supervised and unsupervised. Right. So during, as we discussed, during the training phase, algorithm is exposed to your training data, and we need to adjust the parameters to minimize the errors and also to improve the ability to make predictions. We need to improve it. So by tweaking the parameters, you could able to minimize the errors, and you can get a better accuracy. And we need to evaluate the models to make some accurate predictions, how your model is performing towards your data. Once your model is ready, once your model is trained and evaluated, now it is ready to deploy it in the real world applications to automate your tasks, or to make some recommendations, or assisting the healthcare industry in decision makings. So we are applying these. Machine learning is widely used across various domains and applications. Okay. So when you talk about supervised learning, maybe I can take you to the one slide. Here I have given examples. So look at this image. I have a label data, and I have labels. So if you find a four-sided image, then it refers to a rectangle. If there are no sided, we term this as a circle. If there are three-sided, we term this as a triangle. So likewise, for each and every rows of record with labeled data, we have annotations, right? So we are passing both my labeled data and labels to the machine. I mean, to the ML model. So ML model will get trained, right? So your algorithm is now exposed to your training data, right? So after training your model with the historical data, the next step is I'm just passing only the labeled data. I'm not passing the labels. Now the model has to tell me whether this particular labeled data belongs to which category, whether it is a triangle or circle or hexagon or triangle. So it has to give the results, right? If it gives exactly like triangle and circle, it means that your model is performing well. It is completely 100% accurate. That is one way. Sometimes what happens, it may give you the right result. Sometimes it may give you the wrong result. If you are getting less than 50% accuracy, then we have to play around with the parameters. Okay, so to make a better decision or to make a better predictions to an unseen or new data, we need to tweak the parameters. We need to adjust the internal parameters to minimize the errors. This is called supervised learning, right? So regression and classifications are coming under supervised learning. When you talk about unsupervised, we have only unlabeled data. We don't have annotation for each and every symbols. So we are passing only unlabeled to the unlabeled data to the machine. The model will learn something from the unlabeled data. So we are trying to find the similarity of patterns in the given data. So it finds the similar groups into one category. See here, look at the results. So four-sided comes in one category, one group, and no-sided comes in other group, and five-sided and six-sided comes in other group. Okay. So likewise, based on the similarity of the pattern, the model is trying to group it together, right? So this is another model. When it comes to reinforcement, here the agent gets involved. Okay, here the agents gets involved. In the earlier like supervised and unsupervised, no, how to say, like here in the previous example, we have an historical data. Based on the historical data, you are obtaining the results. When it comes to reinforcement, no proper training. Simply we are passing some input to the data. It is giving you the result. So nowadays we are much familiar with ChatGPT, right? So we are prompting something in the text box, right? It is giving you some results. If you're not happy with the result, you're clicking regenerate option. So when you're clicking regenerate button, it is giving you, it will keep on popping up whether the answer is better, best or worse, right? Hope you might have noticed that. Anyone tried using ChatGPT? Yes. Anyone is familiar with ChatGPT?
Yes.
Yeah. So when you're clicking regenerate, you might have noticed, right, Arifa?
Yeah.
Yeah. So that is again a kind of reinforcement learning. If your answer is, if you give a better response, it takes as a positive reward. If you give the answer is worse, it takes a negative reward. So based on the given feedback, based on the user's feedback, it keeps on adding their responses. Okay. It keeps noted the positive responses. And whenever you are giving the same prompt next time, it gives you the better result. So for instance, the same question may be typed by 1,000 customers. Out of 1,000 customers, 800 customers are giving a better response. Then obviously it will pick the better response. And it gives, whenever you're prompting the same question, it gives the same result to the next user. And that is how it works. It involves a third-party agents here, right? So I have given a detailed description about what is supervised, what is unsupervised, and what is reinforcement. So supervised models are trained on labeled data. So the main objective is to map the learning data to your target labels, the input features to the target labels. And when it comes to unsupervised, it involves exploring unlabeled data. So we are trying to discover some patterns and we are trying to find the relationship between different features. And reinforcement, it focuses on training agents to make some sequence of decisions by interacting with an environments, right? So training autonomous vehicles to navigate the traffic, So I cannot bluntly give like there is a traffic in that particular spot or something, right? So lively it trains autonomous things, right? Automatically it trains based on the current situations which is happening in the environment, the particular environment, right? Right. So where we can apply these real world projects like machine learning projects. So it is not applicable to a particular domain. So we can apply these techniques to various domains like healthcare, finance, retail, transportation, marketing, energy, and entertainments. When you talk about healthcare, we could able to predict the disease outbreaks based on health data, or based on the past 5 years historical data, we could able to predict the disease. When you talk about finance, we could able to find the risk assessment and also credit scoring for loan approvals. And when it comes to transportation, autonomous vehicle navigation and route optimization, right? So we are applying these ML to various industries and various domains, right? Yeah. So programming skills again. So programming skills are the fundamental things in the field of data analytics. If you want to manipulate, if you want to do some analysis with the given data sets, if you want to build the model, or if you want to automate, or if you want to create a pipeline to automate the task, we need a programming skills. So let's try to explore why programming skills are crucial. And here, two programming languages are most popular in the worldwide. One is R and Python. So why programming matters here? To handle your data. So programming allows data analysts to efficiently load, manipulate, and transform your data, right? So we have seen a lot of common issues we'll be facing while dealing with data cleaning and prep, right? Like cleaning outliers, removing the duplicates, standardizing the format. So these things are essential, right? So to handle those things, we need a program. We should have a programming skills and analysis and modeling. So programming language provides some libraries. We have a lot of frameworks for statistical analysis. So with this, we could able to do a lot of analysis, and also we could able to build the models. And visualizations, yes, again, a lot of tools available in the market like Power BI, Tableau, ClickView, ClickSense, Studio, Looker, and MicroStrategy. These are all the, what to say, like the Power BI business intelligence tools. And of course, even without that separate framework or separate tool, we have an inbuilt library like Matplotlib and Seaborn. Even by using that, we could able to create some interactive and customized data visuals, all right? And if you want to repeat the same task, in order to automate the repetitive task, again, we need to create a pipeline. Say, for example, for instance, you can take this. You are using a same data set and we are trying to classify your data, right? So we have a lot of classification algorithms available in the thing. Like we have what to say, like decision tree algorithm, random forest algorithm, naive Bayes, support vector machine, XGBoost, logistic regression. So we have a lot of algorithms. So how can I choose the algorithm? How can I choose the best algorithm for my data? So I need to play around with the models, right? First, I will go with the base model, logistic regression. I will look for the accuracy. I will play around with the internal parameters to minimize the errors. But still, I'm not getting better accuracy. Then what should I do? I should go for the next model, like decision tree. I need to look for the accuracy. So I cannot play with multiple models at one go. So I need to create a pipeline. So I can set a pipeline in one code. So automatically it will, the same data sets will be applied to multiple models. It gives you the accuracy of all the models. Okay. Then we can finalize which model suits best to the given data sets. So that is also the data scientist role. So to automate the repetitive task, which in turn saves your time. And also we could able to reduce the errors. So either you can go with batch processing or continuous processing. It depends. Okay. And most popularly used programming languages are Python and R, but Python is most versatile and beginner friendly languages for data analytics. So again, both languages like Python and R are offer providing some extensive libraries like pandas, NumPy, and Matplotlib in Python. or is particularly designed for data analysis and statistics. And again, of course, it provides a rich ecosystems of packages for manipulation and visualization. So both are most commonly used languages. So there are certain factors to consider which tools you would prefer, right? So both, I mean, 90% of the users are preferring Python, but OR is mainly designed, specifically it is designed for statistical analysis. If you are more focused on statistical stuff, then you can go with OR programming languages, okay? And also it has a lot of packages for analyzing your data. Yes. So why business, I mean, domain knowledge is required? Anyone? Why domain knowledge is required?
Subject matter expertise in
Yes.
a specific industry.
Yes. So why subject matter expertise is required, Arifa?
To provide the level of detail required to answer.
Yes.
Yeah, to meet the demands of the.
Okay,
business.
what you pointed is right, like to give some relevant, I mean, relevant answers, right? Yeah, so whenever we are dealing with some complex problem, though we know like how to build a model, like we know like various tools, we know a lot of tools available in the market, we have lot of algorithms to build the model, but at the end of the day, we'll be getting the result, but we don't know how to infer the data. So we don't know what is the regulatory compliance for the healthcare industry. We are not much familiar about the jargons used in healthcare industry, right? So in order to ask some relevant questions or to interpret your results in a meaningful context, definitely we need a domain expert, right? Some subject matter expert is required when you're when you are working with some crucial projects. When you're working in a crucial projects, definitely the domain knowledge helps you to ask a lot of relevant questions. We can choose some appropriate data sources. Sometimes we may not know whether we are choosing the data rightly, since we need a massive amount of data, right? We are starving for data. So when we are choosing some appropriate data, we don't know like whether we are collecting the data in the right sources. So to get such kind of information, domain knowledge is required. Okay, so these skills are highly interconnected, and also it often go hand in hand in real world data science projects. Okay, it is a combination of all these skills to extract some insights. It's not only about domain knowledge, it's not about only with statistical part, it's not about only what to say, like the programming skills. So all are highly interconnected. Okay, when you're dealing with some real world data science projects, it is a combination of all these skills to extract some information, to make some predictions, and to solve some complex problems. Okay, so with this we could able to we could able to convey their findings, convey the resultant output to the even non-technical stakeholders. Okay, so even we cannot expect the stakeholders are technically strong, right? So when we are working in a cross-functional team, we have to convey the findings to a non-technical stakeholders as well. So these collaboration skills and effective communications are essential when it comes to a data scientist role, right? So tools and technologies. Okay, here I have listed down a few tools and technologies: SQL, Microsoft Excel, Jupyter Notebook, Python, or Tableau, and Power BI. So when you talk about SQL, this is again a domain specific language. So when you want to retrieve the data or manipulate the data or manage your data in a relational database management system, we need the SQL query, right? A lot of tools like MySQL is there, PostgreSQL, Microsoft SQL Server. We have a lot of database management systems. By using this structured query language, we could able to manage and query the relational databases. So that is where SQL comes into play. And next is Microsoft Excel. So this is also widely used spreadsheet applications, again, which offers data manipulation, data analysis, and also visualization capabilities. So when it comes to Microsoft Excel, again, there is a limit like 1 million rows. If you feed more than 1 million rows, we cannot perform these kind of things. So that is where the business intelligence tools comes into a picture. So to solve a complex problem, to hold the voluminous data, we have a lot of tools like Power BI and Tableau. So to do some basic calculations, to create charts, to create graphs, to create a new table, to create a new measure, to create a new column, again, we have a Microsoft Excel. And next is Jupyter Notebooks. This is again an interactive web-based environments. So which allows user to write code, to execute code, and also you can document your work, right? And you can visualize your data even in the same output console. This is like a collaborative a tool. Okay, it's a web-based environments. We can write your code and you can execute your code. And again, this Jupyter Notebook supports multiple programming languages, including Python and R. Okay. And again, Python and R, again, the programming tool languages we commonly used in data science and analysis. You can choose whichever programming language you're comfortable with. And the last two, like Tableau and Power BI or BI tools, business analytics tools, which allows user to create some interactive dashboards. They can create interactive reports. So they could able to connect with various data sources. So which is making it easy to visualize and explore your data in an effective way. So again, each tool has their own benefits. Again, there are certain factors to be considered before picking up the tool. So if you are new to this, there is no point in playing around with multiple tools. We have a Gartner report. By using that, you can pick the right products. Right. Sometimes when we are running a small scale industry, we cannot buy all the licenses of tools of all the frameworks and play around with it. Instead, you can refer the Gartner report. You can find which are all the tools is coming under leaders quadrant. It means that it is competing with the current market standard. So with that, we could able to pick a right tool to perform your task efficiently. Okay, so these are the data scientist, data analyst tools and techniques plays a major role. Yeah, so here I have given two instances for real world application projects. One is healthcare, predicting the disease outbreaks. So in 2014, the Ebola outbreaks in West Africa highlighted the need for timely disease surveillance, right? So we have some historical data with us. We could able to predict disease outbreaks, and also we can enable early intervention and resource allocations. So based on the result, they can allocate some resources, right? So by analyzing data on disease spread and population movements, the projects helped contain the outbreaks, saving their lives and resources. So this is one example. And the finance, like in order to approve the loans process, we need to find the credit scoring and risk assessment, right? So this is again a data-driven approach. We have the historical data with us. We are feeding the data to the model. We are training our model, and we are trying to predict or making some predictions or decisions based on the historical data. Okay, this is another analogy. So likewise, it is not only applicable to the finance and health industry, it is applicable to various industries, as we discussed, financial, transportations, e-commerce, education. Like for example, if you are having some courses, but you don't know whether it is meeting up the current standards, right? Or current regulatory things or something. So we can do some analysis. Accordingly, we can create a new courses, right? So it is applicable to every industry. Even the government agencies can use this ML model to predict, to forecast something. They can predict the weather forecast. So we have the historic records of the weather forecast for the past 5 years or 10 years. Using that, we could be able to predict the weather. So a lot of stuff can be done by using ML models. So today's key takeaway is we know what is data, we know how to categorize the data, and the role of data analytics, and we know like what are the fundamental skills are required. And then if like data cleaning, prep, lot of steps we have seen, and by using that we could able to ensure the quality of your data. And we know what is data visual. So we are representing our data in a graphical way. So with that, we can be able to easily we can grasp the content. And machine learning, which is used to build your model to predict or to make some decisions about the data. And domain knowledge is essential to to solve the complex problems. We can take, uh, uh, we can ask a lot of relevant questions. We can choose appropriate sources to collect the essential things. So for that, domain knowledge is needed. And we have seen lots of tools and technologies, SQL, Excel, Python, or Tableau, Power BI, and ML models. So these are the tools that are required to become a data scientist. And again, data analytics solves a lot of problems. And we are driving some innovations in many industries like healthcare, marketing, manufacturing, transportation, agriculture, retail, finance, and lots more. And if you want to become a data scientist, so what you have to do? See, not only this, what to say, like only with the help of a degree, we could not able to uh, get into a data scientist or data analyst. Though we are pursuing some degree in the related field like computer science, statistics, or maths, that is again the basic criteria. And like just seek for the internship. Like if you get some chances, please, you will be getting some exposure to some real world projects, so which is valuable for building your resume, right? And attend a lot of data analytics conferences, webinars, join some online forums or LinkedIn groups related to data analytics to connect with professionals in the field of data science, right? And also, if possible, try to create some small data science projects. So you can showcase the projects in the portfolio, right? So create some GitHub repository where you can share your code, right? So it demonstrates your coding skills. And start writing some blogs and try to discuss related to some data analysis projects, tools, and some insights about data. So this blogging can establish your expertise, and also it establishes your online presence, right? So build a portfolio based on the personal data projects which you're working with, right? So with this, these way, like you can and of course we have a lot of job boards like LinkedIn, Indeed, Glassdoor. We can search for data analytics position, since it is there. Most of the organization is seeking for the data scientist skills, right? So try to explore more about the things. This is just a master course, like we come to know what are the tools are required, but exactly we didn't deep dive into each and every tool. So each and every tool has various algorithms. We need to play around with it. So try to try to get some internship to exposure to real world projects, okay, which helps you to build your resume. And also please stay updated, keep learning, and you can stay update to stay competitive, right? So a lot of tools and techniques are evolved day by day, so keep learning and adapt to that, okay? And also, if possible, try to add some do some certification programs related to data science or data ML course or deep learning course. Try to attend a lot of workshops. We have a lot of online courses to enhance your skills and stay current in the field, right? So please engage with data analytics communities to stay connected, and you can access to new resources and trends as well, okay? So with this, you could able to showcase your skills. You can pave the way for a successful career in this dynamic field. So that's it about today's key takeaway. Any questions from anyone?
Renu, how do you build that portfolio you were talking about? Like, are there any recommended?
Yeah, so you can create a GitHub repository, Arifa. So have you ever worked with GitHub? So create a repository in GitHub. Actually, we can collaborate easily with other community people, Arifa. Like when you started writing code, you can create your own repository where you can store your code. You can share your code to others. So it demonstrates your coding skills and project contributions.
Okay, thank you.
All right. Thanks, Arifa. So any questions? Any questions from anyone? Hope it's clear. I think you at least you might have learned something new jargons about data analytics, isn't it?
Yes, I feel like it was informative. It was a good start, I feel personally.
All right, that's great. Thank you. Thank you, Arifa. So we'll be running courses as well, Arifa, like we'll be running data analytics and business intelligence tool as one course. We'll be running machine learning course. We'll be running a lot of courses. So maybe if you are interested, our admin team will connect with you. So you can, yeah. So if you're interested, please do connect with us, and you can explore more about a lot of things, Arifa.
Okay.
Yes. All right. So any questions from anyone? If not, we can quickly wrap up our session. Any questions? All right. All right. Thank you so much. Thanks for joining today's sessions. Thank you so much for placing a